All right, so the problem statement that we're going to work on today is 5.20, and the summary basically says, and this is actually a really good example because it's a true life example. When you borrow money to buy a house, a car, or even student loans, or any other purpose, you have to repay that loan. It's not just money that is given to you. A loan is a loan, and a loan means you pay it back. Most times when you borrow money from somebody other than mom or dad, there is interest that you have to pay back. So if you borrow $1,000 and there's interest on it, you're going to end up paying back more than $1,000 because of the interest. You are paying for the opportunity to borrow that money. Does everybody understand how that all works? All right, so the specific purpose, to be specific, all right, suppose you borrow $1,000 at an interest rate of 7.2 per year, and the payments are monthly. Suppose that your monthly payment is $25. Now, the interest is 7.2% per year, but the payments are monthly. So we need to first take that 7.2 divided by 12 to determine what the monthly interest rate is. Once we calculate the monthly interest rate by taking 7.2 divided by 12, which is 0.6%, the first month's interest on $1,000 is $6. Okay? Yes, sir.
I thought you said on Tuesday we were going to go over 514.
If we have time, I'll get into 514 as well. If not, all of the code for 514 is on that Word document, and so it will get you through to where you need to be. Because we have to do 513 to be able to do 514 as an example, 513 sample code or solution code is in Cody, so you can actually copy that out, copy it into Visual Studio, and use that as your basis for 514. So it's very simple. You've got like 3 variables that you've got to add, and there really isn't a whole lot of math that is involved in that one. So yeah, so I figured we would do this one because it's a little bit more math intensive, and I'm hoping that I can also maybe do the one that's 5.30, which is the one on limits, because that one is a little as well. So does that make sense? Okay, so $1,000 borrowed, 7.2% per year, $25 per month. The interest per month is 0.6%. So if I'm making a $25 payment per month, $6 of that comes out right away because it doesn't go towards what is known as the principal, that $1,000. So we take the $1,000 minus 25 minus 6, which is 19. So $1,000 minus 19 is $981. $981. So the second payment is then based on not $975, it's based on $981. So we take 6% times the 981, we get $5.89. $25 minus $5.81 is $19.11. 981 minus 1911 is $961.89. Payment 3 is not based on 950, it's based on 961. Okay, so that's how interest works. Everybody good with that? All right. So our instructions are to write a program that accepts as inputs the amount of the loan, the interest rate per year, and then the monthly payment amount. Enter the interest rate as a percentage. For example, if the interest rate is 7.2%, enter it as 7.2. Don't convert it to the decimal is what it's telling us to do. We're actually, in our math, we're going to convert it to the decimal in the math. Note that if the monthly payment is less than the first month's interest, then after each payment, the loan amount will increase. In this case, the program must warn the borrower that the monthly payment is too low and the loan can never be repaid. Okay? So that's our little like default. So if they don't put in a high enough payment amount, we have to tell them that, whoa, wait a minute, you will never, ever, ever pay the loan back because all you're ever paying is the interest amount. Does that make sense? All right, you ready to rock and roll? Let's rock and roll. All right, so first thing I'm going to do is I've already created my parent folder on my desktop. Inside my parent folder, I'm going to create a program folder. I'm going to call this program Payments. Does that sound good? All right. Now that I have my program folder, I can start Visual Studio. And once we start Visual Studio, I'm going to create a new project. I'm going to verify that Visual C++ is selected. I'm going to verify that Empty Project is selected. And I'm going to change the name to Payments. I'm going to browse to my desktop. I'm going to find my Thursday example parent folder. And I'm going to select my Payments program folder. And then in my program name, I'm going to eliminate the S because my program folder is named Payments, not Payments. So it's Payments. I'm going to keep it consistent. Once you've done that, click OK. Let Visual Studio do its magic. Right mouse click on source file, click source, add source file, add new item. Verify that the C++ file is selected. Rename source.cpp to payments.cpp. Click add. And then I'm going to minimize my Solutions Explorer so that I can then maximize my window and what we can see on our window. All right. Let's start with our element number 1, which is our name it, data, claim it. My application name is payment.cpp to identify that it is a C++ program. And the purpose. And I'm just going to come over here and I'm going to work smarter, not harder. And I'm going to grab this and then I'm going to bring it over here in my purpose and paste it so that I have all of those instructions there. And if you want to just leave your purpose empty for right now, I'm okay with that. All right, now, element 2 is what? Preprocessors. Anybody want to share with me the preprocessors that we should use for this program? IOStream and IOmanip. We're not using strings, so we don't need the string preprocessor. We're not doing any math that takes something to the power of or using square root, so we don't need C math. We're not doing anything hard math, so we don't need H math. So those are the only preprocessors that we really need for this program. What's element 3? Namespace. So using namespace, STD. I call him my allow me to work smarter rather than harder little guy. Element 4 is what? Constants. Do we have any constants? We do? What constant do we have? The interest rate? Actually, no. The user is going to put in the interest rate. That is going to be a user input. Anything else? Nope. There are no constants for this one. What's element 5? Initialize the main. INT, MAIN, outside the parentheses, open curly brackets. All right, so we've initialized our main module. What's element 6? Declare our variables. All right, so in declaring our local variables, we're using double for the majority of them, but we do have one that is an integer, and that's the one that is going to, for months. We're going to create an integer for months, and then the rest are going to be double. We need a double for the loan amounts. We need a double for the interest rates. We need a double for the monthly payments. We need a double for the payment principal. And we need a double for the interest rate per month.
Your monthly is in the L.
Thank you. All right, so now that we've initialized all of our variables, we're ready for element 7, which is executable code with inline comments. So in our executable code, because we know we're working with decimals, because we know we're working with dollars and cents, we need to format our output to show all of the decimal places for dollars and cents. So we're going to format our outputs. How do we format the output? Cout, fixed, show point, set precision to 2. Come outside the parenthesis and semicolon. And it helps if you spell set precision correctly. There we go. And that will eliminate the red squiggly line. All right, now, in our algorithm, which is the logical series of steps the computer must take to complete the task, I can't calculate anything until I have the inputs from the user. So we're going to allow the user to input the loan amounts, the interest rate per year, and the monthly payments. All right, so first thing we're going to do, allow user to input the data. First thing we're going to allow them to do is input the loan amounts. Cout, prompt, enter the loan amounts. And I'm going to do mine with a little $sign to make it all fancy. Outside the prompts, we end the line with the semicolon, bring it in on the next line, and put it in the variable loan amounts. And Cout to end the line. Now we're going to input the yearly interest rate. Cout, enter the yearly interest rates. It's also known as the APR, the annual percentage rate. end of the line. I'm going to do my semicolon, bring it in.